Hello and welcome to today's lesson on graphs. My name is Ms. Mohammed. I'm a teacher of mathematics in Manchester, UK. I teach study skills, growth mindset, and mathematic concepts. I focus more on problem solving and GCSE reasoning questions. Today we are covering linear graphs, distance time graphs, velocity time graph, real life graph, quadratic graphs, cubic, and reciprocal graphs. The first four are both in the foundation and higher curriculum. Quadratic graphs, cubic, and reciprocal graphs are mainly for the higher curriculum. The equation for a straight line graph can be written as y equals to mx plus c, where m is the gradient and c is the y-intercept, which means it crosses the y-axis at c. If we were told to draw the graph y equals to 3x plus 2, the first thing we need to do is have a table of values. So this is called a table of values. We put our x here. We can choose the numbers we want from here. So most of the time the examiner likes to use -3 to 3, but in this case for illustration purposes I've just chosen -2, -1, 0 and 1, and then you just substitute. What I usually do is I just put -2 here, we get -6 plus 2, which is -4, and you do the same for the rest. So this is substitution, which is something we covered in the previous lesson on algebra. Once you have your 4 points, so now I have 4 points, x, y values for 4 points, I can draw my graph. So my y-axis, my x-axis, -2, -4, -1, -1, 0, 2, 1, 5. I want to check if this line is accurate, okay? So I'm in the exam and I want to check if this line is accurate because I want all those marks. So I can check this by going to here. It says y equals to mx plus c. C is the y-intercept. So in this case, plus 2 should be my y-intercept. So that means this line has to cross the y-axis at 2, which it does. So I don't have to worry. I know I've gotten the full marks for this question. Another thing you could try and do is this. So if you had a linear graph, you can check what the difference is, the common difference. In the last lesson on algebra, we learned about linear sequence and the concept of common difference. So this is the same. What is the common difference? So -4 plus 3 gives me -1, plus 3 gives me 2, 2 plus 3 gives me 5. So I know I didn't make any arithmetic errors here. But of course, you would know when you draw the points if there's a point that is not aligned. Okay. I want you to complete this table. So all you're doing is substituting the values of x in here to get your y value and then plotting your points. The coordinate grid should be between -3 to 3 on the x-axis, and I want you to use -10 to 10 on the y-axis. So draw and label the graph of y equals to x plus 1 and y equals to 2x minus 3. What some students do with linear graphs or any other graph is that they hesitate in terms of actually drawing the graph because they feel like it's a long process and they have an idea of how they have to do it anyway, so they don't have to do it. But please pause this video and actually draw the graph and then see if you get it right. So how can you check if you got it right? Well, y equals to x plus 1. This graph has to cross the y-intercept at 1. This graph has to cross the y-intercept at -3. That's how you check your graph is accurate. Okay, so gradient is the steepness of a graph. If you have a positive gradient, the line goes that way. So I usually say up the stairs is positive gradient, down the stairs is negative gradient. So this is going up the stairs and this is going down the stairs. If I have that line there, it says find the gradient of the straight line drawn on this grid. Well, if I had the equation y equals to mx plus c, I would have known straight away my m value would have been my gradient. But in this case, we don't have the equation of this line. All we have is a line and we were told to find the gradient. There is two ways we can do that. So there is one way, which is that, you can choose 2 points on here. So I'll choose this and this. And then I will try and find, using this method, the gradient of this line. So if I go x1, y1, x2, y2, so this will be 0, 3, and this would be 2, 6. So this method tells me that I have to do y2 minus y1, 6 minus 3, over 2 minus 0, which gives me 3 over 2, which gives me 1.5, okay? So this is the formula. I can also do something else. So what if I actually drew a triangle? So I'm going to draw my triangle. So change in y is 1, 2, 3. So if m, change in y over change in x, so that gives me, sorry, it should be here. So that gives me 3 over change in x, 1, 2, because this is my x values, remember? So it's going 1, 2, and that gives me 1.5. You could draw the triangle anywhere, but the thing is, go for the corner. I don't know how to explain this in a more clear way. But for instance, if we were to do this, for instance, let me just use this example. It's not as accurate as this triangle because look, I can go 1, 2, 3, but is this a half or 3/4? How can I be sure what it is? And then in this case as well, I can go 1, 2, 3, 4, 5. Is this a half? Well, I can estimate, but do I really want to do that? This is easier because I know it stops there, so it's 1, 2, 3. So you can use triangles to find a gradient, or you can use 2 points and use this formula to find the gradient, which is the same, change in y over change in x. When two lines are perpendicular, the product of the gradient is -1. When a graph has a gradient m, a graph perpendicular to it is a gradient -1m. So when you're looking at gradient or perpendicular lines, this is what I mean. So it crosses, the two lines cross at a 90 degree. Okay, that's what we mean by perpendicular lines. What they're saying is that if this line, for instance, let's use this example. So if this line, the gradient is 3 over 2, the perpendicular line, the gradient of the perpendicular line will be -2 over 3. Okay, that's what they're saying here. So it's -1 over m. So if this is 3 over 2, -1 over 2 over 3 can be written down as 3 over 2, sorry, can be written down as 2 over 3 minus. Okay, I want to check if this is right. Well, what they're saying is that the product of the gradient, so the product of these two, the gradient of the line and the perpendicular line, if I multiply this 2, I should get -1. So if I do that, so if I do 3 over 2 times -2 over 3, this cancels out, they're all 1. So I do end up with -1. So my negative here and 1. So this is my way of checking that my gradient for the perpendicular line is correct. This comes a lot. The perpendicular line, the gradient of a perpendicular line comes a lot in the GCSE exam. So please master this. All you're doing is, the reason why I went the other way around is because this is a fraction. If it was just a number, if a gradient was 3, then the gradient for the perpendicular line would have been 1 over 3 minus. Okay? Okay, what about if you were asked to the midpoint of a line segment? Then, well, the midpoint of a line segment is the point exactly in the middle. The clue is in the name. The way we find the value of the midpoint is through this. So we would have 2 points, x1, y1, x2, y2. What we're trying to find is the midpoint of this line. So what we're doing is x1 plus x2 divided by 2. Because, you know, with coordinates, the x value comes first and then it's the y value, right? So we're adding the x values divided by 2 to get our x, the y values divided by 2 to get our y. If we have this example, 3, 2, and 7, 9, well, we have to add, so this is my x, and this is my x and y as well. So we add the x's, 3 plus 7 divided by 2, which gives us 5, 2 plus 9, 11 divided by 2 gives us 5.5. So that is our midpoint. So midpoint has to be in coordinate format. So it has to be in x, y format. There's a special type of linear graphs called the linear graphs of y equals to and x equals to. So if I had on a line which is y equals to 1, what this is saying is that the y coordinates on that line will always be 1. So let's look at that example. So what they're saying is this: if I had this line where y equals to 1, all the coordinates here, the y part of it will always be 1. So let's check. If I have -5, so this is x. So this point for me will be -5, 1. This would be -4, 1. This will be -3, 1. This will be -2, 1, -1, 1. So yes, every y value on that line will be 1. The x values will change, of course, but the y value, so on this line, the y will always be crossing at 1. And on the line with the equation x equals to 3, the x coordinates is always 3. So in this case, if I was to draw this line, so this is y equals to 1, this is x equals to 3. Some students try to memorize this and they confuse themselves because they do not understand. If they hear a question that says y equals to 1, they would assume that you would go this way because it has to be parallel to y, right? Y equals to 1 is, no, that's not how it happens. You're looking at understanding what the graph is telling you. The graph is telling you y is always 1. So you know, well, if I draw this line, I know for sure y will always be 1. So if they ask you x equals to 3, draw that graph, then you know, you're like, okay, if I draw the graph here, is x always 3? No, because in this case, x is -5, -4, -3. So it can't be. So it has to be this way, because if I do this, any point here, x will always be 3. It will be -1, sorry, 3, -1, 3, 0, 3, 1, 2, 3, 2, and so on and so forth. Okay, so I want you to answer these questions on your own. Real life graphs. Well, the graph shows the cost of buying different quantities of tomato. What is the cost of 10 kilograms of tomato? With real life graphs, you're reading the graph. You're trying to understand. So this line shows you the relationship between the weight and the cost. So if I have 10 kilograms of tomato, I'm going up 10. So my cost would be 25 pounds. And then it says 1 kilogram of tomato. Well, 1 kilogram would be somewhere here, right? Because this is like that. So this is 1 kilogram. I would assume if this is 5, this would be £2.50. But I always tell my students not to assume anything. Okay? So even though from the graph I can assume it's £2.50, I want to double check if this is actually right. So if 10 kilograms is 25 pounds, so 25 pounds for 10 kilograms, how much would be 1 kilogram? Well, if I'm dividing by 10 here, because 10 divided by 10 gives me 1, I have to divide by 10 on here as well. Look, with the mathematics, all the topics kind of integrate to each other. Now, even though we're looking at graphs, this is ratio and proportion. This topic is called ratio and proportion. So 25 divided by 10 gives me 2.5. So that would be correct. So it is £2.50. So what is the gradient of the graph, and what does the gradient of the graph represent? Again, with this one, we could draw triangles. I'm going to draw my triangles. So it's already started here. I'm going to draw this whole triangle. You could draw any triangle, as I said. Just be sure that it touches the line in 2 points. So it's touching here and here. So that's 2 points. Okay. Last time it was all one gap. But in this case, each has 5 gaps, okay? So each box is £5. So 5, 10, 15, 20, 25. So if I was to go 1, 5, 10, 15, 20, 25, my M is change in Y over change in X. So it's 25 over, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay, so it's 2.5. That's my gradient. Okay, so I want you to do this example. A car uses 1 liter of fuel for every 10 kilometers it travels. Write down the answer, complete the table, draw the graph. I will give you this hint where if it's at the top, because remember the graphs that we were doing with linear, this was X and this was Y. So X is going to be on the horizontal and Y is your distance, okay? And then it says, just so this is a problem solving question. This is the type that you see in the GCSE exams. This is the type. And I can easily sit here and tell you how to solve it, but it doesn't help you because you're just listening to me and you're not actually doing any, problem solving. That's why I'm actually giving you the chance. If I put the answer up, straight away you'll be looking at the answer. I don't want you to look at the answer. I want you to attempt this question and try to answer it, and all the other questions that I have set. Okay, so we have a distance time graph. Jenny walks. This is a different type of graph, right? The one we've just done was a real life graph. This is a distance time graph. Jenny walks 500 meters in 5 minutes, then arrives at this bus stop. The first thing I will do is like highlight it. So this is a typical GCSE question format. So I'll be like, okay, so 500 meters in 5 minutes. And then she waits 5 minutes for the bus. Okay, I'll be like, waits 5 minutes. And then she travels 3,000 meters on the bus and gets off at 16 minutes. So I've highlighted the main points there. It says draw a distance time graph for her journey. So I know straight away distance is going to be on my y-axis. So always label your graph. If it's not labeled, or if most of the time they usually give you this and then you're just plotting the points. But if they haven't, make sure if you want to get the full marks on graphs, make sure you label you have your key, you label your y-axis and then you label your x-axis, and you use consistent values on your x's and y's. So in this case, they're using 500 for each box and 2 on the x-axis. Okay, so 500 meters in 5 minutes. Let me just decipher it. So I know it's going to be 500 meters, and it's saying in 5 minutes. So 5 minutes, I plot my point. And then it says she waited 5 more minutes. So from 5 to 10, she had to wait. So she's not moving or anything. She's just waiting for the bus. And then it says she travels another 3,000 meters and gets off 16 minutes after she left home. So this is where she left home, and she gets off 16 minutes after. You need to be careful with the statements. With the distance time graphs, you need to understand what the statement is saying. And the only way you can do that is if you put yourself in that situation. You go, okay, I've walked 500 meters to the bus stop, and then at the bus stop I waited, and then I traveled another 3,000 meters on the bus, and I get off 16 minutes after she left home. This is the clue, after she left home. It didn't say 16 minutes from when she took the bus. It says 16 minutes after she left home. So basically your end of point is at 16. Okay, but however, how would you know where this is? Well, some of you might think that it has to stop at 3,000 because that's what it's saying. But look, this was the extra 3,000 on the bus. Initially, she did walk 500 meters. So 500 plus 3,000 would be 3,500. It has to stop at 3,500. And that's what we have our point. And then what classic mistake that students make is they plot the points, but they don't join them with straight lines. It says draw the graph. The graph is actually, the lines are the graph. Okay, so make sure you get all your points from a graph question. And then it says work out the average speed in kilometers per hour of Jenny's walk. So average speed in kilometers per hour of Jenny's walk. This is the clue. It's the walk, not the bus, not the wait, it's the walk. So in the walk, 500 meters is 5 minutes. This is the other clue, kilometers per hour. With problem solving questions, you need to decipher the paragraph. So it says walk kilometers per hour, but I only have meters per minute. So I need to change this minutes into hours, and I need to change the meters into kilometers. So 500 meters is 5 minutes. So if I wanted to get to 1 hour, I have to do 60 minutes. So what has happened from here to here? Well, I had to multiply by 12 to get 60. If you don't know how to get this, then do the other way around. What is 60 divided by 5? Look, this is another graph topic, distance time graph, but we're looking at proportion, ratio and proportion. So you times by 12 on this side. Whatever you do on this side, you have to do it on the other side. So if you had to multiply 5 minutes times 12 to get 60 minutes, you have to do the same on this side. Once you get your 6,000 meters, your answer, 500 times 12 is 6,000. Now you need to convert it. Again, this is a separate mathematical topic called conversions of length. 3 topics in one question. So you need to be able to fluently go from one topic to another with ease. So you go 6,000 meters. I know 1 kilometer equals to 1,000 meters. I knew 1 hour is 60 minutes, and that's how I was able to get to this. So if 1 kilometer is 1,000, 6,000 meters would be 6 kilometers. So my answer would be 6 kilometers per hour, because this is 6 kilometers and this is 1 hour. Okay. A distance time graph represents a journey. The vertical axis represents the distance. Always distance is going to be on the y-axis, and the horizontal axis represents the time taken. So average speed is distance over time. Some people confuse this. Speed is distance over time. What I tell my students is this. If I was to ask you to give me an example of a speed limit that you are aware of, you might tell me something like 30 miles per hour, right? You might tell me 30 miles per hour. Well, this is the speed that you've just given me. So speed. 30 miles is distance, hour is time. So this can be written as 30 miles per hour, can be written as 30 miles per hour. So this is my distance, and this is my time. The formula, distance over time, 30 miles per hour. That's how I remember things. And then if you were asked to do time, then this is where solving equations from last time, linear equations and stuff like that would come in handy. So if you need to find time, then you would have to make sure that time is on its own. So you have to multiply by t on both sides. And then you'll have st equals to d, and then divide by s on both sides. So for instance, let me just do that. So if I was told to find t, I would multiply by t on both sides. I would get st equals to d, because these two cancel. And then I'll divide by s on both sides. I'll end up with t equals to d divided by s, distance over speed. Yeah? You just need to know one formula in order to manipulate it, but you also need to know how to do algebra in order to manipulate that one formula. Okay, that was just a diversion. Mike walks to the doctor's surgery. He stops to talk to a friend on the way home. The graph shows his journey. Answer those 4 questions. On a distance time graph, the gradient is the speed. So with the linear graph, the gradient was the steepness, how steep the line is. With the distance time graph, the gradient is the speed. Velocity time graph is another example of a graph. Has time on the x-axis and velocity on the y-axis. The gradient is the rate of change of velocity or acceleration. A positive gradient means an object is speeding up. Acceleration is a change in velocity over time. The area under a velocity time graph is the distance traveled. So I'm going to explain that with an example. What they're saying is this: acceleration is the gradient. So with the distance time graph, the gradient was represented speed. With the velocity time graph, the gradient, this is a gradient, is change in velocity. So that's change in y over change in x. The velocity is on the y-axis. The time is on the x-axis. So it's velocity over time, change in y over change in x. This is our gradient. And then what they're saying is this: the area under is the distance traveled. So this tells us, if the question asks what is the distance traveled, this is what you need to find, the area under the graph. Match each velocity time graph to one of these sentences. Okay, so with this one we would know starts from rest and then velocity steadily increases. It's this one, so it's resting and then it increases steadily. Travels at a steady velocity, this would be it. starts from 5 meters per second. So as it doesn't start from 0, the speed is already at 5 meters per second, and then it's just reducing, increasing, and then starts from 8 meters per second, and velocity steadily decreases. So this is the velocity on the y-axis and time on the x-axis. If we have an example like this, let's go through it together. So the first thing is, what was the starting speed of the particle? It will be here. So I'm assuming it would be 5 meters per second. This is the unit. Remember the units. And then what was the acceleration of the particle? Acceleration, from what I know of velocity time graph, is that it's the gradient. So I need to draw a triangle. Of course, yes, I need to draw a triangle. Okay, so the examiner doesn't actually tell you find the gradient. You should know that when it asks for acceleration, the examiner means find the gradient. So it's change in y over change in x. So my m is change in y over change in x. What's my x? Again, I need to make sure I know the key. So each box represents 10. So it'll be 10, 20, 30 over, and here each box represents 1. So it'll be 1, 2, 3, 4, 5, 6, which equals to 5, that's it, 5 meters per second. Okay, and then it says, what is the equation of the line? What is the equation of the line? So we already know our equation of a line is y equals to mx plus c. So I know my m is my gradient, which I found out is 5. So y equals to 5x. And then plus c. C is my y-intercept, where the line or the graph crosses the y-axis. So this is my y, and this is my x. And it crosses the y-axis at 5. So it's 5x plus 5. That's my answer. As you can see, every new knowledge that you learn is reliant on the knowledge that you already know. So you need to know how to get the linear graph, equation of a linear graph, in order to answer this question on velocity time graph. You need to know how to find gradient in order to answer question on acceleration. Okay? I want you to do this question. Pause the video and attempt it. Fully attempt it. Okay, so quadratic graphs is for the higher curriculum. A quadratic equation contains a term in x squared but no higher power of x. What that means is that you won't have x cubed or x to the power of 4. It can't be anything higher than x squared. The graph of a quadratic equation is a curved shape called a parabola. So if we were told to draw the graph y equals to x squared minus 3, just like linear graphs, we need to have a table of values. So we have it there. In order to minimize my arithmetic errors, I split the terms. So x squared minus 3. So I want to find out what my x squared is, and then minus 3 in order to find my y values. And that's what I have. And I'm going to plot. So y and x. So I'm going to draw my y-axis and the x-axis, and then plot my points. So -3, 6. -2, 1, and so on and so forth, and then draw my line graph, because this is the graph y equals to x squared minus 3. So how can I check? How can I check that my graph is correct? Remember, with the linear equations, I told you can check to see there's a common difference, and then also the y-intercept, plus c. This is the same. So anything that is not related to the x value would mean that this is our y-intercept. So if x equals to 0, our y-intercept is -3. So this graph should be crossing the y-axis at -3, which it does. And so I know for sure that I have drawn my graph accurately. Okay, so I'm going to explain more about this later on. A quadratic graph has either a minimum point or a maximum point where the graph turns. So this is the minimum point, or sometimes when you have it like this, this is the maximum point. When x squared is positive, you have a smiley face. When x squared is negative, so if it was minus x squared, you would have a sad face. So this is a quadratic graph, y equals to a plus bx minus x squared. Straight away, even without looking at this, come on, we need to be familiar with this. So without even looking at the graph, I'll be like, okay, so this is minus x squared means that this will be a sad face or a hill, as some teachers like to use. And then I know this a would be my y-intercept, where the graph crosses the y-axis. Okay, so circle the coordinates of the turning point of the curve. I'll be like, okay, I know it's turning around here, so it'll be 216. So this is it. This is a GCC question, by the way. Circle the value of a. The examiner expects you to know that here a is the y-intercept. And so y-intercept here, so I know it's crossing the y-axis at 12. And then circle the two roots of a plus bx minus x squared equals to 0. When we have something like this equals to 0, this is the clue. So here what they're saying is that y, instead of y now, is 0. So y equals to 0. What did we discuss before? When equation says y equals to 0, then I would have to draw a line that crosses the y-axis at 0, goes across. So this is our y equals to 0. It's not very clear, which is the same as the x-axis. So the x-axis is y equals to 0, because any point here on the x-axis, y will always be 0. And so when it says give the two roots where a plus bx minus x squared equals to 0, what they're telling you is give me the points, or the points where the graph crosses the line y equals to 0, or the x-axis in this case. So it's -2 and 6, which is this one. Be careful, look, they all look similar. Make sure you get that point. It's 3-mark question. Okay, so here's a graph of y equals to x squared minus 3x minus 2. Use the graph to solve the equation x squared minus 3x minus 8 equals to 0. So the first thing I would do is, okay, x squared minus 3x minus 2, how can I go from here to here? And then I'll be like, okay, I can see that I can add plus 6 on both sides. If I add -8 plus 6, I get -2. And on this side, I have to do the same because of this equal sign. Whatever you do on this side, you have to do on the other side. Otherwise, this equal sign becomes invalid. And so once we have that, what did I just mention before? When it comes to this value, it's the y value. This is y. So what they're saying is that x squared minus 3x minus 2 equals to y equals to 6. So where y equals to 6, I need to draw that line y equals to 6, which is this one. If you're not familiar with your x equals to y equals to graphs, you need to master it. So it says if y equals to 6, if I'm not sure, I'll double check. If I put this point here, I know it's going to be -2, 6. If I put this point here, it's going to be 0, 6. So y is always 6 on this line. So now, instead of this where y equals to 0, which is what we were doing before to find our roots, now we find our roots where it crosses the line y equals to 6. So this and this is our answer for x value. And so we look down, it's not very clear here, but x is -1.7 and x is 4.7. I want you to do this on your own. So Carla throws a rounders ball. This table gives data for the height of the rounders ball at time t seconds after Carla has thrown it. So this will be your x-axis and this will be your y-axis. And I'm sure you can draw that graph. A cubic function contains a term in x cubed, but no higher power of x. So it can be x to the power of 2, x to the power of 1 in it, but it can't have, that equation cannot have x to the power of 4. Same thing as graph and quadratic graphs and linear graphs. You need to plot your points and then draw your graph. from -3 to 3. What I want you to do is, once you attempted to draw that y equals to x cubed, try and draw y equals to -x cubed for the same value. So in this case, you'll be putting -3 here to find your y value, and then -2, -1. If you're not confident with negative numbers, please go and master it, because it appears every time. Negative numbers appears in every mathematical concept. So what I want you to do is, after that, reflect what is the same and what is different about this graph and the one you drew before. And then I want you to draw y equals to x cubed plus 1 and y equals to x cubed minus 2 for -3 to 3. Any graph you draw, you need to have a table of values first, and then you plot your points. What do you think the graph y equals to x cubed plus 5 would look like? And what do you think y equals to x cubed minus a half would look like? I would recommend you use the website Desmos to check these two. Instead of drawing them, you don't really need to draw them. You just want to check what happens when you add something else next to the x cubed. This is another example that you can do and draw. Reciprocal graph is y equals to k over x, where k is a real number and x cannot be 0. The reason why x cannot be 0 is that you can't have a fraction where x equals to 0 at the bottom. The denominator can never be 0. So it has two lines of symmetry, y equals to x and y equals to -x. The same concept, you have to draw the table of values, but there's slightly something different here. So before -3 to 3, you just do each number on its own. But with this one, because it's a fraction, you need to have smaller values, and I explain why. So from here to here, you can see there's a huge gap. And then from 2 to 1, there's another huge gap. But if you can see from 1 till 0, so many points are on here that it becomes very hard, that you would need fractions in order to find these points. Okay, so from -1 to, from 0, we don't have 0, of course, because x cannot be 0. So it would always go towards this the y-axis and the x-axis, but it will never touch it. So in this case, we would have to have fractions, positive fractions on this side and negative fractions on this side, between 0 and 1, in order to get these points. Basically, what I'm trying to say is that if you are asked to draw a graph y equals to 1 over x or anything else that is a reciprocal graph, then you would need to add -1/2, -1/4, and a half on there. Okay, and then you substitute your values in order to get your y-axis, your y points. The x and y-axis are asymptotes to the curve. An asymptote is a line that the graph gets very close to but never actually touches. Okay, it's very close to it, but it will never touch. Again, you can use Desmos to prove this point. So write down on Desmos, draw your graph y equals to 1 over x, and try and see if it ever touches the y-axis. This is a GCSE question. Complete the table for y equals to 5 over x. So you can choose any points on here, but however, the x values they've already given you, it has to be between 0.5 and 10. So it includes 0.5 and 10. So you have to have here as 0.5 and here 10, and then you can choose the values that you want in between, and then you put your x values there, you get your y values, and then you plot your points and you draw your graph. These are 4 marks, guys. This is a 4-mark question. What I want you to do now is just take a few minutes, write down hints on how to remember the shapes of different types of graphs, and include sketches in your hints. And then I'll see you in the next lesson. Take care. Bye.